Okay, let's see how you did. Chapter 11 review page. I'm going to give you the answers. So grab that page you did yesterday, page 261, 262. We're going to see how you did, and then you'll need to study these answers. Okay? All right, so we're going to go through these and identify the names of the shapes, okay? This is that weird one that doesn't have the same measurements. This one is it's the one that has the weird name also, trapezoid. The trapezoid sounds like a weird robot or something. So the trapezoid is the weird one that doesn't have, it has four sides, but they're not the same. It's the weird one. Trapezoid's a weird name. Okay, this one's easy. There's 5, 1, 2, 3, 4, 5. We use one each. So is it the square, rectangle, rhombus, or parallelogram? This one is a rectangle, and technically this is the parallelogram, and they're very similar. It's just that rectangles have, what's the difference? You tell me. What's the difference between, technically this is a parallelogram too, because a parallelogram just has to have two pairs of parallel lines, but this one has two pairs of parallel lines. So what's the difference between those two? Yep, I heard somebody, a very smart person say it, or maybe more than one, that this one has 90-degree angles, little corners, exactly 90 degrees. That's what makes it a rectangle, and this one does not. Okay, so we use parallelogram, rectangle. What's that one? That's the rhombus. Rhombus and square kind of go together just like rectangle and parallelogram. See, these are the ones with the wonky sides. So they are parallelograms. This one's a parallelogram too, actually, because it has two pairs of parallel lines, but they're not square corners. These have square corners and these have square corners. Okay, that's the difference between those. Square has square corners, rectangle has square corners, right angles. These two do not. That's the difference. All right, then number 6 says, answer the question. It says, name 2 quadrilaterals that have 4 right angles and have opposite sides that are parallel and congruent. Okay, if it has 4 right angles, name 2 quadrilaterals. It's going to be a rectangle and a square, because those two have opposite sides that are parallel and congruent, and they have right angles. They're the only ones with right angles. Okay? 7, which quadrilateral means 4 sides? Quad means 4. Quad means 4. So if it's a quadrilateral, it has 4 sides, but this one has only 1 pair of opposite sides that is parallel. So only 1 that are parallel and the others are not. Remember, that's the wonky little guy. I'm just making sure I'm right. Yep, the wonky little guy that doesn't have the right, yeah, he's just a little different, isn't he? He's a trapezoid. He still has 2 sides that are parallel, but then he has some weird sides. The other 2 sides are different. Okay, and then the 3 angles of a triangle, total 180. Find the measurement of the unknown angle and classify them. Okay, if it's acute, it has all less than 90 degrees. If it's obtuse, it has one that's bigger. If it has right angles, if it has a right angle, it's a right triangle. So which one has a right angle? This one. So this one is a right triangle. Okay, this one has smaller, and this one has one that's bigger than 90. If it's got one that's bigger than 90, it's obtuse, which only leaves us acute. If it has to equal 180, this is 60 plus 60 is 120. What's that one going to be? 60. So it says to find the measurement of the unknown angle. So the unknown angle here is 60, and that makes this one an acute triangle because all of them are under 90. None of them are more than 90. Okay? Now over here, 110 plus 50 equals 160. So that means this last one, if you take 180 and subtract 160, you end up with 20 degrees. This angle is 20 degrees. We already did this one, 60, 60, 60. Remember I told you if it's got two that are 60, the other one's going to be 60. And this is 60 plus 30 is 90. Do you know what 90 minus 180 is? It's 90, but you should also see that this was a square corner. So you should have known right off the bat that one is 90 without even having to do the math. But if you were confused and didn't think about it, this is the other way to do it. Do 180 minus 90. 60 plus 30 is 90. And that would have given you 90 also. Okay? Boogie on to the next section. Number 11 is a matching section. I love matching because then you always have the right answer, or well, you have the right possibilities of answers. Okay, the lengths of at least two sides of an isosceles triangle are the same. Which one has two that are the same but not three? Because the ones that have all three angles the same is an equilateral triangle. Okay, let's start with that one. That's the easiest one. Which one has all three the same? Right, A. So that's this one. Which one has two the same? These two are the same. So that one is isosceles. That leaves us with the one that are all different. All three are different is scalene. Reminds me of my aunt. Her name was Aline. And I think that's even how she spelled it. Sorry, my brain is not working. Surprise, surprise. That never happens. Okay, Aline, and she was just a little different, you know. I'm just saying that because, I mean, she kind of was, but I'm sorry, Aunt Aline. She's actually in heaven now, so she probably hears me making fun of her. I don't know. Maybe she doesn't. Who knows? Anyway, just think of it that way. Let's call it my scary Aunt Aline. She was not scary at all. That would be a wrong statement to say. My scary Aunt Aline, Scalene, because she's scary because she's different. Isn't that why we are scared of things a lot of times? It's because they're different than what we're used to, and we get scared of things that are different. Okay, so if they're all three different, think of my scary Aunt Aline. Okay, next is translation. Oh, this one's fun too. Translation, rotation, or reflection. Reflection is like you look in a mirror and you see your reflection. So which one looks exactly backwards, like you're looking in a mirror? That would be this one, right? He's standing at the mirror and looking to make sure his hair is done properly, and it's a mirror image. This one's sliding across into a different space. We call that one translation. It's same, it stayed the same, it's just moving to a different place. And this one went and turned itself around, it rotated itself. Rotation. Okay? Boogie on along to the next page. The thing about geometry is it takes up a lot of space to have all those shapes. So they're usually very short. It's going to be a short pages each time, and short tests probably too. Okay, compare the figures. Similar, congruent. Remember, congruent is like Samia and Simran Kokar, if you knew them. They look exactly alike. They graduated 2 years ago, I think. And Kelly and Sarah Campbell, just like Shaylee Campbell, they were a little bit different size, a little bit different looking slightly, and they were similar, not congruent. Okay, so we call this similar. Do you remember the similar sign? I think it's kind of fun. The similar sign was like this, remember?
Calling Liz Hofer. Mobile.
No, cancel. Why? I don't know what I said, but Siri decided to call Mrs. Hofer from something I said. Similar, Siri, similar. They sound similar, I guess, and somehow Liz Hofer got in there. Okay, so that's the sign for similar. These two are the same size and same shape, so we call them congruent. Fancy word for exactly the same. And remember the congruent sign, it didn't say you had to do that, but I'm just reminding us. Okay, draw a line to show two congruent triangles. All you had to do is get a nice And you didn't have to do it nice and straight, but I like things nice and straight. You take it from one corner to the other. If you make a diagonal, it'll make exactly two triangles that are exactly congruent. The same size, same shape, but they're a reflection. So you'd flip it over. Actually, you'd have to flip it and turn it over, and it becomes the exact same size and shape. Okay, can you see number 20? Yes. Name the shape according to the number of sides, and write an equation to find the perimeter. Perimeter, the area around. Okay, so this has 1, 2, 3, 4, 5, 6. What was a 6-sided figure? 6 hexagon. Remember that? Hexagon. They both are 3 letters, hex and 6. They end with an X. Perimeter around. So it's going to be 6 equation. 6 sides times 10 feet each equals 60 feet. That's your equation. Okay, this one is 4 sides, so we call it a rectangle or a quadrilateral. Which one do they want? They wanted you to say quadrilateral because it says according to the number of sides. So if you're just giving it the name for how many sides, it would be quadrilateral. But if you wrote rectangle, I would probably say it's okay. But technically, since they're talking specifically about the number of sides, it should be hexagon, quadrilateral. Quad means 4. Okay, this one has 1, 2, 3, 4, 5, 6, 7. 7 is heptagon. It's 1 right after 7 is right after 6. They both start with HE. And this one's just a little bit heavier. Hept. You gotta hept it up because it's just a little bit heavier than 6. And then 1, 2, 3, 4, 5. Did you guys look up the building I told you to look up for the Pentagon? It looks a lot like that shape right there, Pentagon. And I just realized I got excited about all the shape names. I forgot to do the equations. All right, we did the first equation. This one is side times side. Oh no, perimeter. 2 of these, 2 of these. So 2 times 8. So we're going to write 2 times 8 in parentheses. Plus 2 times this, 2 times 4 equals 16 plus 8 is 24 yards, not square yards either. Okay, heptagon has 7, so we're going to do 3 times 7 equals 21 centimeters. And this one has 5, and there's 6 each, so we do 5 sides times 6 inches each equals 30 inches for that perimeter. See how easy this is and how fast it is and how short it is? Now we're going to find the area. Okay, the area is the measuring of the inside of something. Okay, this is a simple figure. This is more complex. Okay, so on this one we just do 10 times 10. So this is 100 square feet. It didn't say you had to write the equation, so if you did, that's fine. And you can't see that. It's okay if you didn't write the equation this time because it doesn't say to. So you could just write the answer, 100 feet. This one, you have to add the 2 together though, because there's 2 different shapes there. Okay, this one, okay, so this line right here is this line plus this line. So 5 plus 1 is 6. Oh, but we don't need that because we're not measuring that. We're measuring this one. I did it again. I did that yesterday, didn't I? Okay, so 5 times 2 is 10. This box is 10 centimeters. 1 times 4 is 4. Add those together, you get 14 square centimeters. Okay, then down here, this time we do write an equation to find the area of the colored part. Okay, so we're going to do it just like this and subtract half of it, remember? Okay, so on this we're going to do, let's see, we're going to do somewhere, I don't care where, 40 times 20, okay, equals, put your zeros, 2 zeros, and 4 times 2 is 8. 800 square millimeters. Okay, and half of 800 would be 400 square, not centimeters, 400 M&Ms, 400 square M&Ms, 400 square millimeters, I think I said meters. Okay, same with this one, 30, gotta write the equation, 30 times 30 millimeters equals, pull your zeros over, 1, 2 zeros, 3 times 3 is 9, 900 square millimeters, and we need half of that. Half of 900 is 450 square millimeters. That's it for that, and only 2 more. Story problems, 28. Mr. Gray is putting a new grass in his front yard. He will cover the area with topsoil. We learned about that in science. First, then the length of the yard is 55 feet and the width is 30. What is the area of the front yard? Okay, so it's length and we're doing area. So we're going to do area equals length times width. Okay, so we're going to do 55 times 30. 5 times 3 is 15, so it should be 1,650 square feet. Okay, that's a weird T, but that's feet. Okay, estimate this, estimate, we like that. That means times 3 instead of times 3.14 pi. Okay, estimate the circumference, can you see that? Estimate the circumference of circle A, this is circle A, by rounding pi. So make it easy to do in our head. Round by 3 to the nearest whole number. Okay, here's my head, that's that little point in the middle. And here's my hands, that's my arm, radius, radius, radial bones, radial bones. Okay, so diameter is 12 times 3. So it says, I think they wanted to think 3. This is the think thing. Instead of 3.14, right? Think 3 times 12, which equals 36 centimeters squared, because this is the area inside of the circle. No, circumference, my bad. It's the circumference, so it's not squared. It's going around. My bad. Okay, so that's the end of that. And we're ready for our test tomorrow. Make sure you understood how we did this. Rewind and go back and say, how did she do that again? Or ask parents. Or if there's something you still are confused on, please let me know. Email me or text me, and I can either do just a video for you or explain it to you, however we need to, and be ready for the test tomorrow. Alrighty.